Hi there. Today we're going to talk about reasoning in algebra and geometry. We did in class this little riddle thing, brain teaser, where we could write your age and in the end figure out what, do all these different things to it and kind of predict what your answer would be. And all those kind of little brain teasers that work like that always have a algebraic reason why they work. And that's why they're kind of tricks, and then you do enough algebra to it, nobody knows what you just did. We're going to talk a lot about the reasoning in algebra and why we do the things that we do and why that works. And so a lot of properties and rules and stuff today, but we'll kind of go quickly through some of this stuff. Hopefully you kind of are familiar with some of it. So properties of equality. When you're doing algebra, you sit there and you're moving stuff from one side to the other side, and there's properties that allow you to do that. It's the whole thing. If you do it to one side, you have to do it to the other. Okay, if you decide you're going to add something to both sides, we call that the addition property of equality, or the subtraction property of equality. Just whatever you're doing to both sides, that's a property that allows us to do that. Some of the new ones that maybe you're not as familiar with, maybe would be like the reflexive property. Okay, and we do this a lot in geometry. The reflexive property just says that whatever you have on one side of the equal sign, it's going to equal itself. We oftentimes use it with segments or angles or something, and you'll see why later on. But that's the reflexive property. I think of it as a reflection. You have the exact same thing on both sides. The symmetric property is the one where you come down and you're doing some algebra problem and you're solving, and then down at the end, you end up with something like 7 equals x. But we kind of like to rewrite it. We like to switch it around and say x equals 7. Well, which way you write that doesn't matter. That's the symmetric property that says that. Doesn't matter which way you write it. The transitive property, this is another one that's going to be a big one that we use a bunch. And that's kind of comparing three different things. If you know that A is the same as B, and you know that B is the same as C, then we can say that A would have to be the same as C, and that's called the transitive property. Substitution property is when you know that A and B are the same thing, and anywhere that you see A, you can take B and you can replace it because they're the same value. All right, got some more. The distributive property, we use that term when we use it, so you probably know that one very well. The distributive property just says you have this value, you can distribute it through the parentheses, and you end up with A times B plus A times C. We use that a bunch. Okay, now these properties of congruence, this is the thing where I was talking about like the reflexive property. Now we're talking about not just are things equal, but it also works for congruent. If I want to say this segment is the same as this other segment, we use this congruent. If both sides are the same, then that's reflexive property. Works angle A congruent to angle A. That's reflexive. You can switch the order. Remember, symmetric switches the order around, but you can do that with a congruent instead of just an equal. This is the same as if I switch it around. Transitive property, same deal. If angle A is congruent to angle B, and B is congruent to C, then A is congruent to C. All right, so transitive property, all these properties just with a congruent sign instead of an equal sign. Today we're not really learning any new math. What we're doing is justifying the math that we already know, using all these properties I just went through with you. Here's an example where you have this linear pair, and we know that a linear pair is going to form this straight line and it's going to add up to 180. So we could take this expression plus this one and set it equal to 180 and go solve for x. That's what we had previously done. Now, here's going to be the justification why we know that and why we're allowed to do all of that. So we'd start off and say, all right, so I'm looking at that picture and these two angles are supplementary. And the reason that I know that is because a linear pair are supplementary. Now, the next thing, and this is just like what's going on in my head. Okay, they're supplementary. That means they're going to add up to 180 because they're supplementary. That's the definition of supplementary angles. They add up to 180. Now what I'm going to do is I'm going to substitute these values that I already know for those two angles, and that's substitution property. Now I'm going to do some algebra. Now I don't love this one right here. This is not my favorite. They call it distributive property, and I don't think of it myself as the distributive property. I think of it just like simplification. I'm just going to combine like terms. So keep that in mind when you're doing Math Excel homework. And maybe you want to make a note out here to the side that says this is when you're combining like terms. I call it just simplifying or combine like terms. They call it distributive property. They're pulling these two like terms and calling that a 3x plus 30 equals 180. The next step, and just thinking, how would I solve this? Well, I'd move the 30 to this side, and how would I move it? Well, I would subtract it. So that's the subtraction property that allows me to do that. And so then I would divide, so the next step is the division property. And so I'm kind of thinking, what do I need to do? And over here I'm just doing it. And that's how I solved. This is called justification for all the algebra that we've already done. All right, so let's try one. It says, what's the value of x? Justify each step. I'm given that ray AB bisects angle RAN. Okay, this is a different problem than that last one. If this is an angle bisector, okay, so here's how this works. And this is kind of what we're going to do today. We're going to have lots of writing today. So I'm going to start off and say that ray AB bisects angle RAN. And that's just given to me. I just know that because it's given. Okay, great. Now, what does that mean to you to say that AB bisects angle RAN? Well, remember that an angle bisector cuts the angle into two equal angles. So I'm going to come right back and I'm going to say the measure of angle RAB would end up being equal to the measure of angle BAN. And why is it that I know that? Well, because it's an angle bisector. And anytime you think, well, that's because that's what it is, that's always a definition. It's the definition of angle bisector. Next thing. Okay, so now they're equal. Got it. Let's go ahead and substitute our values in. Let's do some algebra. The measure of angle RAB is x, and the measure of angle BAN is 2x minus 75. I just did substitution there. I just replaced it with something that it was equal to. All right, then I'm going to do some algebra. I'm going to subtract the 2x on both sides. You don't have to show this minus 2x unless it helps you. So I'm going to end up with a minus 1x equals negative 75. And what I just did there was subtraction. That's how I got to that. I subtracted on both sides. So subtraction property says I can do that. And then I'm going to divide by negative 1, and here we go. X is 75, and that was the division property that got me to that stage. All right, this right here, that's what we're working on today. The algebra part we already know. Let's practice, do you know why you get to do all the things you get to do? All right, so let's look at this one. It says, what is the name of the property of equality or congruence that justifies going from the first statement to the second statement? All right, so if you look at example A here, it looks like they moved the 9 to the other side. How do you think they'd move that 9 to the other side? They'd subtract it. So it's called the subtraction property. All right, this next one, O is congruent to W. W is congruent to L, so O and L must be congruent. Do you remember which one that was? That is the transitive property. Okay, next one. Let's see what they got going here. Angle E is congruent to the measure of angle, or I'm sorry, the measure of angle E is equal to the measure of angle T. Now they've flipped it around. The measure of angle T equals the measure of angle E. Oh, they just switched it. They switched the order. So switching the order, and you'll kind of be dependent on looking back at your notes on today's until you get the hang of that. But that one is called the symmetric property, when you switch the order around. All right, so on your homework today, you'll have like probably some multiple choice or drop-down menus of different ones of these properties, and you have to decide which one it is. Okay, so let's see if you can do a couple of them on your own. See if on this A through B, Can you justify each one of those reasons? What reason would it be? And then go ahead, I guess, and try D down here. There's a fourth one down there. Go ahead and pause the video, do those 4, and then come back. All right, here's what I came up with. Take a peek and look and see if you agree. The only one that I'm really going to talk about is C, because it all depends on how you would solve this. You can think of it as I divided both sides by 1/4, but usually we don't divide by fractions, we multiply by the reciprocal, so maybe you multiplied both sides by 4/1. That would be multiplication. Either one of those would work for me. Ultimately, here's what we're shooting for. We're going to start doing what we call a 2-column proof. And it's kind of like what I had just done previously where I made 2 columns. I didn't really do it quite as formally as this, but this is what we will be doing. A 2-column proof is a convincing argument using deductive reasoning, justifying each conjecture with a reason. So going through that, and every step you take, you have a true property, theorem, definition, some deductive reasoning there to justify why you are allowed to do that. And so it's going to look like just like this one where they give us some information. We start off with some given information, and ultimately this is going to be our goal. So they're already going to tell you what the end result is. You don't really have to go figure it out. They tell you, here's what we're shooting for. Maybe there's a picture with it. You're going to start off and there's going to be this initial statement that's given to you. And you're going to say, oh, and then this because of this. And then I can do this because of this. And I can do this because of this. Until you get down to the end where this is what you were shooting for. And this is the reason you can do that. Let's start with one that has all the statements figured out for it. And we just have to do the reasons on it. So looking at the picture, they've started off and they have the measure of angle 1 is equal to the measure of angle 2. And they have that marked in the picture. Got it. And what we're trying to say is that if you take the measure of angle AEC, that's this one here, AEC, it should equal the measure of angle DEB. And you can look at that because if 1 and 3 are the same, and then you're just including 2 within those scenarios, that would still be the same. All right, let's see if we can prove it. It says measure of angle 1 equals the measure of angle 3. All right, that was given information. So we just write given. That's what we can write. Okay, the next one says the measure of angle 2 equals the measure of angle 2. Because ultimately they're both going to end up using that. So we're just clarifying, hey, angle 2 is the same in both of these. What was that property that says the measure of angle 2 equals measure of angle 2? Reflexive. Remember, it's like a reflection. It's the same thing on both sides. That's the reflexive property. All right, now what they're doing is they're taking the original statement here, got the 1 and the 3, and I know you can't see colors in your notes, so that's why this is kind of helpful. And what I've done is I've taken this measure of angle 2 and I've added it to both sides. Now, since angle 2 is the same on both of these, I've added the same value to both sides. That's just the addition property. I can just add the same thing to both sides. All right, now what? Let's look at this. It says that the measure of angle 1 plus the measure of angle 2 is going to be equal to the measure of angle AEC, right there. Add the 2 little ones, it equals the big one. Do you remember that from previous chapters? Add the 2 little angles, it equals the big angle. And then if you come back and look at the second part of what they did, they said the measure of angle 3 and the measure of angle 2, that's these two, will add up and be equal to DEB. Well, again, adding the 2 little angles equals the big angle. I'm stalling for you. Do you know it yet? Angle addition property. Remember that? Now we go to the last step, which is what we were trying to prove. The measure of angle AEC, this one here, is equal to the measure of angle DEB. That was the prove statement, so we know that that's always what we wrap up with at the end. But why are we allowed to say that? And it comes back, if you always want to look back and say, where did I last use that? AEC was here, DEB was here. Why am I allowed to say those are equal? Well, because 1 plus 2 is equal to 3 plus 2. Oh, those are equal to each other, so what they're equal to. Oh, that was just a substitution. And so for this 1 plus 2 right here, I put in the measure of angle AEC. I substituted that in because they're the same. And this right here, I've replaced with DEB. So I just substituted. That's substitution property. All right, and that, ladies and gentlemen, is a 2-column proof, which is something that we're going to do here for the next few chapters. We'll throw some of these proofs in. So let's practice this because it's a kind of a tricky concept when you first get started. All right, so here you're on your own. You got statements and reasons. It says you're supposed to do it, but I'll do it with you. It's your first one. Let's go ahead and do it together. I'm going to start off, and I'm going to put in my given statement. That's how you always begin. The segment AB is going to be congruent to segment CD, and that's given. Now, they had the picture marked, this little segment, same as this little segment. What I'm trying to show is that AC, that's this piece, is congruent to BD, right here. That's actually the same proof we just did, only it's with segments instead of with angles, because you have these two parts that are the same, and then you have this middle part that is, you're going to kind of add to each one of them, but it's going to be the same both times, so it'll end up giving you the same value. All right, so we're really following that previous proof pretty closely, only you're dealing everything segments. For step 2, the part that we're going to be adding in on each of these segments is BC, so I'm going to clarify right off the bat that BC is congruent to BC, and that's reflexive. Now, I think previously we had equals on that previous proof. It was equals, and now I'm doing congruences. I just kind of want to keep it the same as whatever the given was. This is all in congruence, so I'm going to be doing everything in congruence. Okay, here's the third step. Now, I've got this AB congruent to CD right here. And now what I want to do is I'm not really wanting to shoot for AB. I want it to be AC. I want this whole thing. So I'm going to take the AB that I already have, and I'm going to add to it BC. But then I also don't really want to be dealing with CD. I want to be dealing with BD. So instead of this, I'm going to add the BC to that. All right, so then I'm going to do that addition step. So I'm going to take, instead of having AB is congruent to CD, I'm going to say AB plus BC is equal to, or I'm sorry, should be congruent to CD. That's what I'm pulling from step 1, but I'm going to add to it BC. So I added the BC to both sides. When you add the same thing to both sides, that's called the addition property. All right, step 4. Now I'm going to go back and I'm going to look at this AB plus BC that I have written. And I know from my picture that when I take AB plus BC, it should equal AC. Add the two little parts, it equals the big part. I'm going to write segment AB plus segment BC is going to be congruent to segment AC. Add the two little parts equals the big part. That's segment addition. Instead of angle addition, it's segment addition. And while I'm at it, I'm going to do the other one in the same step. So on the other side there, I have my CD, and I'm going to add C or BC, and I'm going to say that's going to be the same as BD. Add the two little parts, it's going to be congruent to the big part. That's all part of segment addition. And if you keep this organized like I'm trying to do here, you don't really have to add in another reason. That's all part of step 4. Now, step 5 is going to take this AB plus BC that I have right here. Okay, yes, those are the same. And then that's equal to this, okay, yes. these two things are equal to each other, so these two things are equal to each other. And if you look at those two being equal to each other or congruent, that's what I'm trying to prove. I'm ready for it. I'm ready for the last step. Segment AC is congruent to segment BD, and that's substitution. Very similar to our last proof. It's just with segments instead of angles. All right, one more. This is really an algebraic proof. So we're going to be doing geometric proofs probably more, but as we just get started, we're going to kind of build it off of something you're familiar with, which is all that algebra you've been doing for years. And so this is more of those addition, distributive, subtraction, division properties. So this is called an algebraic proof. And they give us an original equation. We're trying to solve it, but ultimately we're not trying to solve it, we're just trying to justify the solving of it. So if you look at this right here, the first reason, that's given. It's always given to us. Something has to be given. The second step, you look at what did they just do. Looks like they moved the 1 to the other side. How did they move the 1? They subtracted it, so that's the subtraction property. All right, and then the last one, what did they do? Looks like they divided both sides by 5, so that's the division property. You'll probably find that these algebraic proofs are a little bit easier for you because you're more familiar with the algebra steps on it. All right, I hope this helped today. Good luck on your homework.